Hi everyone, welcome back. We are going to start today our last section of the chapter, section 8.6, solving rational equations. So again, we are continuing on with our fraction, but today we're solving. So inside the fraction, there's going to be a variable. We're going to end up solving for them. And we're just going to jump right into it, okay? There are going to be 3 steps when solving our rational equations, okay? So I'd like you just find a little space here and write down your 3 steps, okay? The first one is going to be find the lowest common denominator, okay? We did this a little bit last section. We're going to do a little bit more today, but again, it's going to be fairly simple denominators, okay? And then the second step is we're going to multiply each term by the lowest common denominator. And I know that seems weird. It'll make more sense in just a moment, okay? But what happens when we do this is when we multiply by the lowest common denominator is it makes all the denominators disappear so that the last step is just solve for the variable, and it makes it really easy to do that, okay? And so that'll be the last step that we need to complete, okay? Just like last class, we are going to keep it very simple, so we're actually not going to do all except one of these problems, okay? So just kind of like start crossing this one out. We're going to cross this one out and cross this one out. I'm going to show you a few different examples on how to complete these problems, okay? So for A, we are going to instead have the equation 1/2 plus x equals x divided by 10. So this is going to be the problem we do instead. Again, we're going to keep it rather simple here. Okay, so go ahead and cross A out and write this problem instead. And so we're going to follow our steps. Our first step is to find the lowest common denominator. Okay. So our lowest common denominator, denominators are 2 and 10. So hopefully you see that the lowest common denominator is 10. Remember, the lowest common denominator is the least common multiple. So multiples of 2 are 2, 4, 6, 8, and then we finally get to 10, and that's going to be the first multiple that's common to both. So it's the lowest common denominator is 10. Okay. Then we are going to take that 10, the lowest common denominator, and we will multiply every single term times 10. On the left side and on the right side, after pluses and minuses, every single term gets multiplied by 10. Okay? And the reason for this is now going to become clear right now. Okay? On this first one, 10 times 1/2, we can reduce. 2 can go into 10 5 times, and then 5 times 1 is just going to be 5. Okay. The next one, there's nothing to reduce. X times 10 is just going to be 10x. And then on the other side of the equal sign, I can reduce 10 divided by 10 is 1, so it's just 1 times x or just x. And now look, it is an equation with no fractions whatsoever, and it's a simple linear equation that we can solve, okay? And so now we just go to solving, like moving all our x's over to one side, and there are multiple ways of doing this. I'm going to subtract 10x to the other side, okay? And that leaves us with 5 is equal to a negative 9x, and again, I'm solving for x, so we divide by negative 9. Okay, that goes away, and we get x is equal to a negative 5/9. And we are done. We've solved for x. Okay. Now, because there's no variables in the original problem in the denominator, we know that this is okay. There's no restrictions. Remember those restrictions from section 8.4? This is where it becomes really important, okay? Because if I had a restriction, then I would need to make sure my restriction wasn't actually an answer. But there was no restrictions on this problem, so your answer of x equals negative 5/9 is totally perfect, and we are done with the problem. Okay. All right, let's go to B, but again, we are not doing B. We are going to do a new problem, and let's make it, here we are, 2x over 3 minus 1/2 equals 2x plus 5 over 6. So this is the new problem we are going to do. So go ahead and write that down. Again, going back to the restrictions, you can see here the denominators 3, 2, and 6, there are no variables, so there are no restrictions on this one. So whatever our answer comes out to be is our answer. We don't have to worry about, like, did it really fit, did it not fit, okay? So let's go ahead and start. Just like the last one, we want a lowest common denominator, okay? So between 2, 3, and 6, okay, the lowest common denominator is going to be 6. 3 goes into 6, 2 goes into 6, 6 also goes into 6, okay? So we're going to take that 6, and every single term is going to be multiplied by 6. So don't leave anyone out, okay? Times 6, and then over here on the other side, times 6. And from there, you're going to start reducing so that the denominators go away. If you end up with the denominator after doing all of this, you've done something wrong. You've either have the wrong lowest common denominator or you've reduced wrong, okay? So you should have no fractions left over. So 3 is going to go into 6 2 times, and then 2 times 2x is going to be 4x. And then 2 is going to go into 6 3 times, and 1 times 3 is 3, so it's minus 3 equals, and then 6 divided by 6 is 1, and so I'm just left with 2x plus 5. And you can multiply, it's obviously 1 times 2x plus 5, but distributing 1 to 2x plus 5 is just 2x plus 5. And now it's just a simple linear equation. I'm going to subtract my 2x to the left side. I'm also going to add 3 to the right side. Okay. So 4x minus 2x is 2x. And then on the right side, 5 plus 3 is 8. And when I finally divide by 2, I get my answer as x equals 4. This is a perfectly acceptable answer because there were no restrictions, and we are done with this problem. Okay? All right, so hopefully that's not too bad. You're seeing the common denominator. You take it, you multiply to every single term, and then reduce so that there's no more denominators, okay? Now let's look at another problem. Again, another one that is not on this sheet. We're just going to write a new one in, okay? Let's write it over here under C, okay? So our new problem for C is going to be 1 over x plus x over 3 equals x plus 5 over 3x. Okay, so this is going to be the new problem we do. Okay. All right, so just like I know now we have a variable in the denominator, but all the steps are the same. The only restriction is that x can't be 0. So as long as our answer is not 0, we'll be okay. Okay. So we look at the lowest common denominator. If you look at the denominator, there's an x, there's a 3, and then there's a 3x. So we need a 3 and we need an x, and that's going to be our lowest common denominator. So x can go into 3x, 3 goes into 3x, and 3x also goes into 3x, okay? So we need the 3 and we need the x, but once it's there, it's already common now, okay? And so our lowest common denominator, 3x, same thing, we multiply every single term by 3x. Okay. And now we are going to simplify. Okay. So on this first one, I see x divided by x cancels to 1, and we're left with 3 times 1 is 3. On the next one, I have 3 goes into 3 one time, and we're left with x times x, which is x squared, so it's plus x squared. And then on the other side of the equal sign, 3 divided by 3 goes away, x divided by x goes away, and we're left with just x plus 5. If there was a number there, you would have to distribute it to x plus 5. Okay, so if it like reduced to 2, you'd do 2 times x and 2 times 5. Okay, but there's not. And so now we have 3 plus x squared equals x plus 5. Okay, now because it's an x squared, this type of problem we need to set it equal to 0. Okay, and we will solve our quadratic equation. Okay, so we're going to set it equal to 0. So I'm going to subtract the x over. I'm also going to subtract the 5 over. Okay, and I'm going to put it in order. So we start with the x squared, and then I have minus x, and then 3 minus 5 is a negative 2, and that'll equal 0. And then we go through and we factor and we solve our factored form. Okay, so needs two numbers that adds to a -1 in this case. This is going to be a -1 and multiplies to -2. Okay, so my factored form here is going to be x minus 2 and x plus 1, because -2 times 1 is -2 and -2 plus 1 is going to be -1. And then the final steps of solving, you either get x minus 2 is 0, so x is equal to 2, or x plus 1 is 0, so x is equal to -1. And so you have two answers, okay? It just means that both of these answers will work, and it's okay. Remember, the restriction was that x couldn't be 0, okay? And neither of these answers are 0, so both the answers work in our original problem. And we're done. So sometimes you're going to get problems and you're just going to solve a linear equation, and then sometimes you're going to get it where you have the quadratic and you have to factor to find your answer, okay? And that's going to be about it for those, okay? I do want to do one of the problems on the got it's, okay? We're not going to do D, but I do want to do E here, okay? Actually don't even think you have a homework problem like it, but this kind of problem does come up a lot in like SATs, you know, your SBAC testing, which we're not doing this year anymore. Maybe on the final exam you might see it, okay? But these problems come up a lot, and that is so the reason why I want to do it is because it's one fraction equal to another fraction. And whenever you have a fraction equal to a fraction, you can cross multiply. You don't have to worry about common denominators, okay? So it's one fraction equal to another fraction, so we can cross multiply here. So it's 4 times 2x plus 3 equals 5 times x plus 2. And notice there's no more denominators again. You didn't have to worry about a common denominator. And so again, this comes up a lot like on your standardized test. So that's why I wanted to throw it in here. And then you just go through and solve. Like I'd have to distribute this 4 to 2x plus 3 and we get 8x plus 12. Okay. And then distribute the 5 to the x plus 2, we get 5x plus 10. And then we solve just like we have so many times before. I'll subtract my 5x over to the left. I'm also going to subtract my 12 to the right. And so we get 3x is equal to a -2. And my last step will be to divide by 3 on both sides. And we end up with x is equal to a -2/3. Okay. And if I took a really quick second to look at the restrictions, my restrictions on the first fraction, that x couldn't be -2, and my restriction on the second fraction, x couldn't be a -3/2, and so we're okay. -2/3 works. We are okay with this answer, and we are done. So again, I don't think, this is really bothering me, I don't think you're going to have a problem like this in your homework if I remember correctly, okay? But these kind of problems do come up on standardized tests a lot. So when it's a fraction equal to a fraction, you can always cross multiply to solve for a variable, okay? All right. That's it for solving the equations. We are going to come onto the second page and we're going to do a couple of these examples where we solve for the given variable, okay? We've done these before, but now we're looking at dealing with fractions. And so we're going to do example A and then example E, and we'll be done with this section, okay? So we've done this before. We want to solve in this case for B. So B is going to be our only variable. The A and the H we can almost treat kind of like numbers. Like if it's being multiplied to B, we would divide it. If being added to B, we would subtract it. We always want to undo the operation so that B is all by itself. Now the difference is from what you've done before is B is in the denominator, and you've never had to really do that before, okay? But like I was just talking about in the last problem, we can say that H is a fraction H over 1. And now what do we have? We have a fraction equal to a fraction, which we can cross multiply. Okay? So it's H times B equals 1 times 2A. Okay? and you've cross multiplied, and now there's no longer a b in a denominator, okay? And so then you're going to go through and you're going to solve for b now. H times b, we're solving for b, it's being multiplied by h, so I'm going to divide by h. And so we get b equals 1 times 2a is just 2a, and then it's over h. And that is solved for b now, okay? So cross multiplying was able to get the b out of the denominator, and then we solved for b by undoing the operation, so I divided by h because it was being multiplied, and we have our final answer, okay? We've solved for b. In the very last problem we're going to come over here and do the got it, and we're solving for x now. Again, dealing with the fractions. So x is part of x plus y plus z. I cannot subtract y and z right now because all of this is being divided by 3. So before I even think about subtracting, I got to get rid of that division of 3, and I'm going to multiply by 3 on both sides. Okay? And so what we have is 3 times a is 3a, and then the 3's go away. That's why we multiply by 3 on both sides. Okay? And then we're left with x plus y plus z. And now hopefully you see it's fairly simple. I'm trying to solve for x so I can subtract the y and subtract the z, undoing the operations. Subtract it to both sides. And we have 3a minus x minus z. That is, oh, excuse me. That was supposed to be a y. My bad. Okay, this is supposed to be a y. Sorry. Okay, change that to a y. All right, there we go. Now, 3a minus y minus z, that is equal to x. And we have solved for the variable x now in our equation. Okay. And that's it. That is the end of the chapter. You do have a textbook assignment for 8-6. So you're going to want to do that and Dropbox it to me in School Loop. And always make sure if you have any questions, you email me and I will try to get to them. Take care, everyone. Goodbye.